Hello everybody to our new video about the Rust programming language. Today I'll show you a bit more about lifetime. So I would advise you to learn about lifetime by watching actually the video of John Jensen. The video is here. Actually, I put the link below the video, because it explains basically everything. What I'm gonna do today, it's something a bit different. I will take a very simple case and I'll show you, I'll try to do something less common and see what's wrong with this method and why we cannot do that. And this way we are going to learn more about lifetime, about how the objects are allocated by Rust and deallocated also. So let's create a new project first. Okay, so let's consider we have a structure. Data, for example. And this struct, in this struct we have a content, and this content is an option. It's important in our case to use an option. I'll show you why. Of string. Why not? We have that. And then we want to implement some method. So we want to implement method, and the first one to implement will be get content. So we can say that our structure has a default value in this case, and the default value could be, for example, for the content, it would be none, let's say. So let's create a constructor first. And we use the default value for the, yes, for this, it's none. Yes, that's good. So the content, the method, so it's a ref to start, and we can, this is interesting. Usually what we do in this case, we want to have the content of the real content. I mean the string here. We want the string here, not the option, but the string. So let's consider we want to return a ref star. So to do that, we just unwrap correctly the option. So we do sum of, so I'll explain a bit, but ref to let's say our content. We want our content, content. It's basically equal to self content. So that's it's gonna unwrap the option here into this. So we can do that differently, and then we can return the information here, and also we want to return empty string in the case it's none, so it's else. Here we can use the else. Yes, okay, whatever, you use the else or not if you want, if you don't want to. So what's going on here? Very simple. We can do a matching like that, a pattern matching, okay? But if you do that, it will simply unwrap the string into this, into the C variable. But we don't want a C, we want a reference. So we do that. So in my mind, what I use the ret here, the ref here, I consider it not being part of the pattern matching, and I apply it after the unwrap is done. So in my mind, it's like, okay, we first get a string, and then we want a ref to this string. We can do differently. We can do something like that as ref. That would be exactly the same. I think we should prefer this way of doing things. But never mind. For now, let's keep it like that. Okay, so when we return C, it's a ref string, but because we can automatically convert a ref string to a ref star before being returned, it will be converted to ref star, and this it's actually a constant to ref star, so it would work. But something we didn't talk. So okay, let's call it ref content 1. You need a lifetime here. Let's say hey, tk, sorry, tk and tk. So what we are telling Rust here is that the value we want to return, it is linked to the original object, linked by the lifetime. It means that it must have the same lifetime. Okay, so because of this, and the default, there is only one lifetime possible here, is tk. Okay, so we can get rid of it. But for clarity, I prefer to do this, to say, okay, be careful, we need a lifetime here. So I just leave the underscore here to make clear that. So let's test everything now. So test one for the first routine. Okay, we need a data, and we are going to return something. So this is a case where it's been known, but we can also create a data like that with content and it's an option, so it's a sum of something, and this something will be hello, and we need a string. How we do that? Okay, so we have a data, sorry, with let's call it D for the data, and then we can call the get content underscore 1. So let's try this. Okay, get hello. So that's neat. Okay, this is a common way to do when we want to extract a value from an option or something like that. We return a value that is definitely linked to the original object by its lifetime. But what's going on here? You say, yeah, it's linked to the original object. But what about this one? No, this one is not linked by its lifetime. This one is static. It has a static lifetime, which is bigger than tick A, let's say. So it works because you will never live longer than the static object. So it's compatible. This is why it works. And it's very important for what will follow. Okay. So I get to look at my plan. Okay. So now we want to ask ourselves interesting questions. What about if we want to return a ref string instead of a ref stub? Okay, we want to do something like that. Just want to do another method. Have that bigger. And we want something like that. String. It's a ref string. It's not very common. Why is not very common? Can we do this? Can we try to do it? Well, apparently this one is a ref string, so why not? And because the lifetime of self will be, for example, tk, this lifetime will be tk as well. So no problem with that. We have the same lifetime. But what about this? Okay, we also need a ref string here. And that's a problem, because in the case of none, we don't have anything to refer. So we say, okay, we need something to return anyway, a string to return. So say, okay, it's a default string. It's a default in case of none. So the only thing we can do for now is to say, okay, let's use a default value in parameter. And the default will be a ref string, because this is what we want. Okay, and we return the default here. Yeah. Okay, let's try it. We're going to have another test. Say test 2. There, and this time we want to we try this case and the default also. So let's try with D1, with D, okay, with a ref, and we have a default value that will be, for example, my default value to string. Okay, we pass this, and this has its own lifetime. So it's going to be weird because in this case, you say, okay, we need to have the same lifetime. So this should complain because we don't know that this is the same lifetime. But why not? We can decide it's the same lifetime. Okay, why not? So in this case, we are going to use a TK here and TK here and a TK here. Okay. And because it's not implicit, we have TK. Okay. So we expect those two parameters to be the same, to have the same lifetime. So let's try this for now. Oh, I mean this one. Call get content 2. Get content 2, yes, I will get 2. So I will get 1. Okay. So let's run this one. Yes. So what do we have here? We have a string that is created here inside the method call. And it has a specific lifetime here. So this specific lifetime is not the same as D because it's not the same scope as D. So it doesn't have the same lifetime. So it's interesting because we see that we create an object which is like a temporary object and it's not the same lifetime. So what about this one? Default. So it's interesting because now we have hello. So we managed to make it work by extracting the expression from here to here. Unlike the other languages that will consider the previous expression and this expression as the same, in Rust it's not the same. It's not the same because of the lifetime. And that's very important to understand. Here you have a specific scope. But it seems to work. We have another case to test when we let D0 data new. So in this case it's none, right? So we can consider the same default value and the same call and do this with a 0. Let's change the 0 here, not to put the confusion. Here we are. So we have my default value. So it's perfect. It works. But now, can we go further? Can we say, okay, we want the same, a ref string, but in this case, we don't want to use the default. We don't want to use the default. We want to use just nothing. I still have a default. No, still have a ref string, I mean. What can I put here? Well, it's complicated. Because you are telling the compiler that you actually want to return a reference to something. So something the original code will not own because it's a reference, but this value doesn't exist really. I mean, so if I created it here, and I return the reference to that. So let's call it let default and return def. What's gonna happen? If you compile it, obviously it doesn't work because it says that actually, oh yeah, there's a bug here. Yes, okay. You return something that is owned by the current function. And it makes sense because the program, this one, for example, that calls the method, doesn't know anything about what we are going to return because the memory will be deallocated here. So you're going to return something that doesn't exist actually. So we are doomed. We cannot do that. To do that, we should be able to do something that don't think is possible. If you know something that can do that, let me know. Static, something like that. For example, default. That will be something like static string equal box, and you have to lick it because it's totally static. So, and you can put something here. I don't know what, but maybe there is a way to do it. Not sure it's very interesting because in the end, what you are going to put here is something like a ref stir, more or less. So it's a bit stupid to do that because we want, if you use a ref stir, you use this one. So, but if we could do that, you could imagine and to do something like that, def, to return a def here, by default. But in the spirit, this is what we should do, definitely. Symmetrical that to this one because we have a ref stir and a ref stir, and this we should have and with a static here, and we should have a static here. Okay, but this is not possible. Okay. So we say, okay, we don't really like this default value here, and we still want to return something that would be close to a ref string. But we say, it's different stuff here and here. Okay, so what about string? Because Rust forces us to use string more or less here. So let's consider the routine that will return a string. Okay, let's build one. Let's call it 4. Clone it and let's do something like that. And here you have the constant you want, but let's say new value, it is a string here. Okay, so this one should be correct, and we can have a test. Let's do a simple test. Oh, let's do the same as this one. As this one, so test 4. We no longer need a default. So this one is a string. So I don't want to consume it, so let's do this like that. And it's the same for this one. C0, no default, C0. Okay. Let's try it. Okay, we have empty string here, and we have hello for our case of test 4. So it makes sense, because what we do here, we simply create another string object. Okay? So there is a small cost of creating an object, but when you think of it, you don't have a choice, because in this case and in this case, it's not the same type. You cannot merge them to a common type here. If you want a ref, I mean. So in this case, it's totally two different objects created separately, and in this case, you return this one, and when it's done, you return this one. So you say, yeah, but we return a string by value, not by reference. But not really. Because in Rust, even when you have that, when you have the references, it doesn't mean you have you don't have a copy of the value. It's not like in Pascal or something. It's simply to tell the compiler that you move the information. You move in the sense that you give the ownership to someone else. It doesn't mean you copy the value. So it's interesting. So let's, explain that a bit by displaying something interesting. Okay, let's do that. Let's do something like that. So the object is a string here, okay, and say it's a mutable string. By the way, it would be nice that an object would be mutable only once. Maybe it's ridiculous, but no, I say that because in our case it's not really mutable. It's because we initialize the object separately, so but it won't change. So we do that. We return the object, but before this we will print it and say, for example, object is in memory, let's say that here, and we put something like that. We display the p, it means the pointer, the form of a pointer, okay? Then we have a reference of object here. Okay. And we are going to do exactly the same thing in our test. For example, let's say this one. Just to know the pointer, the C address. So the object is C here. So what you see is that the address, it's exactly is not the same at all. Oh yeah, yes, they are the same. I was confused by the second call actually here, but those two addresses are exactly the same. So what happens? It's that when we return a string, we actually return the address of the object, not there is no copy at all. So it's very efficient. So don't have to worry too much by returning a string. But in this case, obviously, when we do that, we give the ownership to this function, and the C object is totally owned and by test 4 and will be deallocated here. So I think it's interesting to understand that, and why we cannot return easily or impossibly a ref string. So I hope you liked the video.